that?
The center of the object where its weight acts.
Yeah, not quite enough, no. Because it might not even be the center. The center of gravity might not be the center.
The point where the object's weight acts due to gravity.
That's it. The center of gravity is the point. The center of gravity of an object is the point in the object in which all the weight appears to act. Not even going to write that down because, boring. And you would make me very sad if you didn't get that. Did you get that, KJ? What did you say it was?
The weight going perpendicular to the ground.
No.
The area.
No, zero. Second, what did you say?
Force due to the substance.
No. Karar, what did you say for the first one? The center of the gravity is the center of the gravity. No. Wow, guys, you screwed it up for 1 mark. That's disappointing. Right, let's have a look at the next one here. So you've got a door. And the door is held against the wall here with some hinge. I don't need to draw the wall, but it's here. So there's a reaction force here. I think it's called P. And there's another reaction force which they drew going this way, which I call Q. And then there's a downward weight here. This distance is 0.39. The total length of the trapdoor, though, meters.
What's the trapdoor?
Just a door on the ground, on the floor. And this is 35.6 newtons, is that right? Oh, and you know that this angle here is 40 degrees. And the question is, determine the mass of the trapdoor. And do we know the weight? We don't. We have to do some calculations. So basically, the question is 9 marks. No, look up time. The question is 9 marks, and it could have said, the question could have simply said, find the things you don't know, because we don't know the weight, and we don't know the P. We don't know its value, and we don't know its angle. Here we know the angle and the value. So the question literally could have just said, find all the things you don't know. And that's how I'm going to proceed, in whatever order I feel is easiest for me. So when I look at this, I first have to decide what type of problem this is. Well, what type of problem is this? It is, but more specific than that. It is a cantilever problem, but not really. Thank you, Karan. Very good. It's a 3-force problem.
Like anti-clockwise.
No, not this. Not this. So, it's a 3-force problem. Do you remember what the key idea about the 3-force problem is? The key result, the key theorem. No. Huh?
Upwards equals downwards?
No. No. It's gone. The 3-force theorem states that when 3 forces are acting on a body in equilibrium, all the forces must meet at one point. Yeah, now you see, you have a test in the summer and you're forgetting this stuff. No, but you're not revising, and you're leaving too much to revise, because not only do you have to revise stuff from the start of the year, you have to revise stuff as recent as the last lesson. So in other words, everything. Okay, so we know that this meets here. So it means that we know that this one here will be 0.85 minus 0.39. So that is 0.46. Now, what else can we know? We know that that's 90 there. What else can we know? Oh yeah, so
Time.
because we know the base here and we know the angle here, we can know this height because we could say that sine 40 equals the height over 0.46 if this is the height here. So I can get 0.46 times sine 40. So I know that this piece here, I'll draw it in, is 0.296 high. Now if I know the height and the base, I can super easily get this angle here, which I'll call theta, because I can say theta is tan inverse 0.296 over 0.39. So I have the theta already is 37.2 degrees. So I can know what the horizontal part is. It must equal the horizontal part here. Now notice how the order I'm doing it is quite different. I'm actually doing this part second, the second part first. I'm trying to find the angle and the value of P before I find the mass of the trapdoor. So in my head it's easier to switch these around. This is not unusual. We've seen this before in physics questions in the exam. Sometimes it's easier to do the second part first. It is perfectly fine as long as I mark this as B part 2. So we have P cos theta must equal Q cos 40. Now look, we know the theta, we know the Q, and we know this, so we can again super easily get the P, and I already have part 2 of the question done for 6 marks. P is Q, 35.6, times cos 40, divided by cos 37.2, so I get 34.2 newtons. So I can know how much the vertical part is here, and I can know how much the vertical part is here, so therefore I know what the weight is. So I can say now for part 1, the weight will equal P sine, P sine 37.2 plus Q sine 40, and I know the P and the Q. 34.2 times sine 37.2 plus Q, which is, what was it, 35.6 times sine 40. So the weight must equal 43.6 newtons, but of course weight equals mg, so now I can finally get the mass. The mass is 4.44 kilograms. So very quickly, within, my goodness, like 5 minutes, I have 10 marks. I have 10% of my exam finished in 5 minutes. If I continued at this rate, I would have a 3-hour exam finished in 50 minutes. But of course, most students got this question wrong, because most students, like you, go into the exam too confident. True, too confident, too complacent. They think they know what they're doing, and we had a whole lesson on these types of problems in semester 1. You remember the ladder against the wall and the ball against the wall. You all forgot what type of problem this was, how to do it. Okay. So the key with the physics, like I said, the difficult thing is not doing the question; it's starting the question. So it was easy for me to do this. Wasn't easy for you to start it. Let's have a look at the C part. So you have an object at rest, and there's a force acting on it for 0.2 of a second. What's the velocity? Okay, so let's have a look here. C, part 1. So it is a 10.85 kilograms. And there is a 125 Newton force being applied for a time of 0.2 of a second. It's a small time, 0.2 of a second. And then it's initially What is the velocity afterwards? Okay, so what formula could we use here? Well, or what type of problem is this? Any ideas? I want the velocity. It starts at rest.
You can use the,
Use what, speak up?
no way.
This is 10.85. Come on.
What you said?
What?
You said something.
I can't hear you. What?
You said something.
You said something. Great. What's the something?
No, what I said is
They want the velocity after you apply this force. Come on, wakey, wakey, wakey. What do I do? Oh, no, no, no. This is taking too much thinking time. This is terrible. What do I do?
Use the formula for, we can find the acceleration.
Yes?
Then we can use acceleration to be some like V, U, AT.
So all I wanted you to say was U, V, ATS. That's all. It's taken too long. So U is 0, V is what we want, A we don't know, but we can know it, T we know, S we don't know. And how can I get the A?
F is equal to
Yeah, Newton's second law, F equals ma. 125 equals 10.85 A. So 125 divided by 10.85, 125 divided by 10.85, you get A is 11.52 meters per second. So how can I get the V? Good old V equals U plus AT. The U is 0, so it's just the A, which I have on my calculator, multiplied by T. So the answer is 2.3 meters per second. Now in the B part, what happens, the second part, is that this object collides with another object of 15.62, moving in the opposite direction at 3.67. So it's collision now. Right, so we need to carefully draw what we have. So firstly, we have them separate. This is 10.85 kilograms, moving at 2.3 meters per second. And then this one here is 15.62 kilograms.
Yeah.
Initially moving in the opposite direction, so minus 3.67 meters per second. It's heading to the left. Initially moving in after the collision, object B continues to move in the same direction at a speed of that. So they collide. After the collision, you don't know what the first one is doing, but you know that the second one continues to move in the same direction, so it's still moving to the left of minus 1.210 meters per second. So that means the other one must be moving to the left as well. So I'll say minus V. The V will be positive. Because it can't be moving to the right if the other ball is moving to the left, because it means it passed through it, which we don't allow in physics at the moment. So the question is probably to find the V, is it?
What if you jump over?
Find the V. Look, it says find the direction. I'll be shocked if the answer is positive. It means they really screwed up this question. It could be positive. That would mean my V would need to be negative because I have a minus in front already. You don't have to put this minus in. If I drop it, then it means I'm expecting my V to be negative. Right, so this is M1 U1 plus M2 U2 equals M1 V1 plus minus M2 V2. So it's super easy here. 2.3 times 10.85 minus 3.67 times 15.62 plus 15.62 times 1.21 divided by 10.85. I do get a negative number. V is minus 1.24 meters per second. What is the total change in kinetic energy? Explain why there's a change. Well, I already know the part B answer. It's due to heat loss. So let's just calculate the change in kinetic energy, part 3. Do I even need to do this? You get the kinetic energy before the collision, so that's a half M1
collision.
v squared plus a half the other one, and its speed squared, the kinetic energy after the collision, a half that one. What was its speed? 1.21, wasn't it? 1.24 squared plus a half the other mass, its speed squared, which is...
Is it as a result of the collision?
Yeah, there'll be some heat gain when they collide.
It's going to be after the collision.
Yeah, this is an English thing. There's a loss in the kinetic energy resulting from the collision. The collision caused a change in change in energy. There was some loss in when it collided, heat was produced. So it should say, yeah, due to collision, as a result of the collision. Yeah.
So we should use just after the collision, not the whole thing.
No. Account for this change in kinetic energy. There is a change in kinetic energy because heat was produced during the collision.
The third one.
Huh?
I'm talking about the third one.
Oh, the third one?
Yeah,
Determine the total change in kinetic energy. Yeah, what's your question? No, seriously, what's your question? What are you asking me?
Determine the total change in kinetic energy of objects A and B as a result of the collision.
Yes.
So just after the collision, because you use the values of the kinetic energy before the collision.
What are you talking about? I got the kinetic energy just before the collision. That's the first one.
Yeah.
And now I'm getting the kinetic energy just after the collision, and I'm going to subtract them. I'm not sure what you're asking me. So before the collision, there's 133.9 joules of energy, and then after the collision, there will be less because some heat was produced during the collision. So there's a lot less after the collision. A lot less. There's only a mere 19.8 joules. So the loss in kinetic energy.
It's like 15%.
It's a huge amount. So this became heat energy. It's what I was saying in part 4. This loss in kinetic energy wasn't a loss. Well, I mean, it was a loss in kinetic energy, not a loss in energy. It just became heat energy. This question was very badly answered 2 years ago. Very badly answered, with very few, maybe no one, getting it fully right. I don't know why, because I would hope as you're looking at this now, what was difficult about this question? I mean, we've done this in class, we've done this in class, we've done this in class, we've certainly done this in class, we've definitely done this in class and this in class, and we've done this in class.
This one is difficult, the 3 course.
Oh, I did it with the ladder against the wall. It's the same principle. You have a weight, a reaction, and a reaction. So it's the same deal, just on the ground. A reaction, and a weight. It's almost exactly the same, except instead of the ladder being against the wall, it's a door on the ground. A trapdoor. But I mean, my point is, every single thing, like every single question here, was like an example I did in class. Almost directly like an example I did in class. So if you're revising, if you're doing the homework, if you're looking over the notes, you should do fairly well in this test. If.
Just a matter of if.
If you're doing this, you'll do well. How long, I don't know, that question probably took me about 15, 20 minutes, That was number 1. So in this exam, number 1 I thought was good. Number 2 was maybe, it was okay. Number 3 was good. It was like what we did in class. 4 was good. 5 was good. And 6, we've done this one in class. And this was good too. So I don't think these physics exams are too difficult. Honestly, I don't. At first I thought they were a little difficult, but now, after doing a few of them and teaching them for a little bit, I realise these are all good, doable exams. There's nothing super weird or super hard in this. If you wanted a good grade, Karar, you could get it. If you wanted badly enough.
Sorry?
If, never mind. Alright, we're finished there.